So today we're talking about fertilizers again, but looking more at some of the math side of it. So calculating ppms and millimoles. So let's get into that. So we're going to talk about how do we make a fertilizer, right? Well, it's not much different than how do you make a cake. So you start with your ingredients. You have to weigh them out, measure them, combine, and mix, right? One of the trickier parts with fertilizers is we need to know exactly how much of each component there is. And much like weighing out for baking, we have to sort of know that a certain volume of whatever, if it's flour, is the same so that every time we make it, it's the same. And so what we use is what we call standardized units. And the mole is something that maybe not everyone has heard of if you didn't do any chemistry in high school. Um, no, not the mole on your face, but a mole is and not guacamole, but it is a unit of atoms. And the best analogy I can come up with is a dozen eggs. So, for example, 1 dozen, if I said we have 1 dozen eggs, you would know exactly how many eggs I was talking about. You would say, oh, that's 12 eggs. It's really no different. When I say 1 mole, it means that I have 6 times 10 to the 23 atoms of a particular atom in my hand or in my cup. So if I have a dozen eggs, if I have 1 dozen, I know I have 12 eggs. I have 1 mole, I know I have 6 times 10 to the 23. Obviously, it's a very big number, but it's irrelevant. It's the same thing. We're just counting individual units and representing them with a term, like 1 dozen or 1 mole. So obviously we can't count atoms like it says on the slide, so we weigh them. Just like if you were going to count a dozen eggs, you could put 1 egg on a scale and weigh it, and then you know, hey, 1 egg is 75 grams. And then you would just keep adding eggs to your scale until you had 12 times 75 grams, which is 900. Once you reach 900 grams, you know you have 12 eggs. Um, it's much the same at a hardware store. Like if you want to order, say you need to order a lot of nuts and bolts, what they do is they weigh one nut, let's say it's 1 gram, and you say, well, I need 5,000 nuts. Well, then they'll just keep adding nuts to the bowl until they hit 5,000 grams. And then they know they have 5,000 nuts. It's really just the same with fertilizers, right? So we take an individual weight, and with atoms, that's called molecular weight. Okay, so at the bottom here, we have calcium nitrate, which happens to have a molecular weight, MW, of 164. Let's never mind the units right now. Let's just say, okay, calcium nitrate has a molecular weight of 164. It's no different than my nut example or the eggs example. Okay, so that's the weight of calcium nitrate. Um, Now I have added water molecules to this because typically there is reagent grade or research grade and fertilizer grade fertilizer. And certain chemicals, like calcium nitrate in particular, are what we call hydroscopic, which means they absorb water. Typically, those are the kinds of salts that, they turn into a lump when they're sitting in an open bag because they pull moisture out of the air. Um, a lot of those chemicals are put into little sachets that you'll see in your shoes or your wallet that you buy. And the reason they put those little sachets in there is because those chemicals will absorb moisture inside the shoe or the wallet so it doesn't get moldy while it's in storage. So anyways, calcium nitrate, what we do to find the weight of 1 egg or 1 nut or 1 calcium nitrate is we add up each individual atom that is in the entire molecule, and then we add them up. So here we've got calcium. There's only 1 calcium. Each individual calcium is a molecular weight of 40, so that goes over here. Then we have 2. There's N here, and there's 2 times that whatever's in the bracket. This is like math, I know. I'm so sorry, and I'm making a mess of it. There's 2 times whatever's inside the bracket. So there's 2 nitrogens, all right? So 2 times 14, 28. There's 10 oxygens. So there's 3 here, times 2 is 6, and 4 times this, that gives us 10. That's 160 molecular weight. And then how many hydrogens? 4 times 2 is 8. we have 8. We add up all these units and we get the molecular weight of 236. Now, before you all start to really panic, just know I will not ask you how to calculate the molecular weight of a specific molecule, because in the real world it's given to you, right? So I'm not here to make your life miserable, but I do need to give you the tools how to function in the real world. The real world, those numbers are available and you will need them. So that's the molecular weight of calcium nitrate, the fertilizer grade. All right, now as I said here, eggs, they can vary. If you go to the grocery store, there's small, medium, large, extra large. Can't ever really say I can tell the difference between large and extra large. So maybe I'm just a large person. I don't buy the extra large. I don't want to pay that because I can't see the difference. You tell me next time you see me. I don't know. But anyways, so when we're looking at molecules, we do have to remember that we have to make sure you're looking at the fertilizer grade. So not reagent grade calcium nitrate, but the fertilizer. Again, in the real world, this is going to be provided to you. And in this course, I will only give you fertilizer grade molecular weight. So again, don't worry too much about that. Now, to be fair, I have had students go off to very small companies like cannabis startup companies where they were ordering reagent grade chemicals that, paying a lot of money for not having the water molecule. And one of the problems is if that's stored for any length of time, this quickly becomes that. And then your calculations are off significantly. So you should be aware of that. This is the molecular weight of calcium nitrate. This is the fertilizer grade. That's a big difference. Your numbers will be way off if you don't factor in that. Again, I will make sure that in any questions or assignments you get here that's clear. So anyways, what that means, okay, we go back to the molecular weight, so 216 for calcium nitrite tetrahydrate. That means that 216 grams, if we just add grams to that number, is equivalent to 1 mole, just like what I said about a dozen eggs. So that means that there's 260 grams of calcium nitrate, means there's 2.6 times 10 to the 23 individual molecules of calcium nitrate in your cup, all right, or what we call 1 mole. So there it is again, 236 grams, and if we put it into a liter, 1 liter, then it's a 1 molar solution. So that's the basic chemistry. That's about as complicated as it's going to get. Now with fertilizers, we typically deal with much more dilute concentration, so millimole, which means we divide by 1,000, or it's 1,000 times diluted. So all you do is take your decimal place and move it over 3 times because you're dividing by 1,000, right? And that becomes 0.236 grams per liter, or turn it to milligrams, so 236 milligrams per liter gives us 1 millimole. Or, more importantly, 236 ppm. Now, you've all heard of ppm probably. ppm is related to fertilizers in the broader context. Now, I'm going to tell you that in the commercial world, people tend to use millimoles in the vegetable sector and ppm in the floral sector. It is interchangeable. Now, basically, in the floriculture world, things are far less precise. It's a different crop, different growing styles. It's not nearly as precise. In the vegetable sector, where margins are very tight and yields are very important, fertilizers are dealt with on a more precise scale. So millimoles is what the typical industry would be using. But milligrams per liter or millimole is the same as ppm. So here I have an example. Let's say we're dealing with potassium nitrate. That is a molecular weight of 101. All right, that means if we put 101 milligrams of potassium nitrate in 1 liter of water, we have a 1 millimolar solution, or 101 ppm solution, because milligrams per liter is ppm. If we double that to 202 milligrams per liter, it is 2 millimoles, or 202 ppm. So the key thing here to remember is that 1 milligrams per liter is the exact same thing as ppm. Okay, so ppm stands for parts per million, same as milligrams per liter. Another important thing to remember here is in the horticultural world, I've already last week talked about how fertilizers typically are identified as three numbers, 2820 or 20-20-20 or 15-5-15. Those refer to nitrogen, phosphorus, and potassium in that order. And in horticulture, if someone is given instructions, let's say you look up how to grow poinsettias, and they'll say feed your crop at 100 ppm for the first 3 weeks. Once the true leaves show, then switch to 80 ppm. What are they referring to? Because fertilizer is a mixture of chemicals. So the industry standard is when they give ppm instructions, they're referring specifically to nitrogen, which is the first number in your fertilizer bag. Okay, the rest just follows. So they're always referring to nitrogen. Some growing instructions will actually say 50 ppm nitrogen. When you look at a fertilizer bag, 2820, what it's referring to is percentages. So 20% nitrogen, 8% phosphorus, and 20% potassium. Okay, so if, for example, I'm being told we need a 200 ppm solution of 2820, we're actually referring to 200 ppm of nitrogen. Okay, that means that we know that 20% of whatever we weigh from this particular fertilizer is going to be nitrogen. Okay, so even though what we have up here is a mixture of different fertilizer components, if we take whatever we weigh, if we weigh 400 or 1,000 grams, 20% of that is going to be nitrogen. The rest will be phosphorus and potassium. So let's work through a math problem. Yeah, there's some math. This is about as much math as you get in this course and in almost all the courses. So I'll work through a couple of examples, and then when you have your quiz, online quiz, you'll have a chance to work through that. Now the quiz will have multiple attempts, so don't panic, okay? For the most part, I view quizzes as a teaching tool, not a means to knock your mark back. So don't panic when you get it wrong in the quiz. Just figure out what you did wrong, and then the next time you do it, get it right. So that when we get to the midterm, you're able to do this. And if you are having problems, bring a sheet to the lab, and I will work through it with you, okay? So let's walk through this. Remember, ppms is milligrams per liter. Say 200 ppm is the same as 200 milligrams per liter. Again, just reviewing. This is the formula that you want to remember, okay? Your desired ppm times 100 divided by whatever the percentage in your fertilizer label is, okay? Will give you the number of milligrams you're supposed to add to 1 liter of water. That's important because in some of the quizzes, I might say how much you have to add to 20 liters. Start with 1, and then all you have to do is multiply it by the number of liters in your tank, okay? Remember that trick. So, for example, if you want a 200 ppm solution of 2820, right? So that's 200 milligrams per liter. ppm is milligrams per liter. Getting a lot of lines here. Let me clear them up. Times 100 divided by the percentage of the fertilizer, right? That's 20%. 20% equals 200 milligrams per liter times 5 equals 1,000 milligrams. So 100 divided by 20 is 5. That's how we got the 5. This is 100 divided by 20. So that means that we're multiplying, we're going to end up having to weigh more, right? Makes sense. If you want 200 milligrams of nitrogen, but only 20% of what you're weighing is nitrogen, obviously you're going to be weighing more to get that 200 milligrams. So this formula just corrects for that. So that means we need 1,000 milligrams per liter, and 1,000 milligrams is the same as 1 gram. This is unit conversion. You should have learned this in school, right? A milligram is, mil is 1,000, if you know your French. So 1,000 milligrams per liter is 1 gram. So that means if we're putting 1 gram of 2820 into 1 liter of water, you will have a 200 ppm solution. It's important that you go through this. You can watch the video over again, walk through this again, make sure you understand how to do this. So let's try a 1 liter, 300 ppm solution of 15,515. So what percentage of that is nitrogen? 15%. So there's the formula. What's our desired ppm? Times 100 divided by the known percentage of nitrogen in the fertilizer. So the desired ppm is 300 times 100 divided by 15 from the fertilizer, right? For nitrogen equals 2,000 milligrams, which means 2 grams goes in every liter of water to make 300 ppm. It's a lot of lines everywhere. Okay. Next, let's talk about fertilizers in the agricultural context. Typically, we concentrate them. That's for convenience. It's too difficult to make them dilute all the time. In vegetable farms, you have to make them dilute because we release the entire nutrient solution out to the crop, and then we bring it back and store it and use it again. So it's recycled. But in the ornamental world, that's typically not the case. So we have to have a stock tank with concentrated solution in it that gets mixed through this injector into the water as it goes out to water the crop. That was just a horrible line drawing there. Anyways, so concentrated fertilizer allows us to use longer intervals between mixing. That's true. Gives us flexibility, which means we can adjust the injector if we want it stronger. Say on a sunny day we want more feed, or on a cloudy day we may want a lower dose. It also allows us to have multiple tanks, right? So maybe we have 2 tanks in here, and one is 2820 and the other is 15.5 or 14.014. Or for example, like last week I talked about rotating fertilizers to make sure we have constant proper feed. So we might have a tank for 2820 and then 14.014 and then Epsom salts. So how do dosers work, right? So normally they dilute a stock tank, they suck up into an injector from a stock tank, and they dilute water. Water comes in and mixes with the fertilizer and then exits. And depending on how this part here is set, we can control how concentrated or how weak the solution is. Anywhere from 50-to-1 to 500-to-1 dilution. Now, obviously, one injector doesn't do it all. They sell injectors that have sort of a useful band of adjustment. It's too hard to have an injector that does everything. So in a simple cart doser, like you see on the right here, you place your concentrated fertilizer in the bucket, and then that gets diluted. Typically, we leave it at 100-to-1. That's the most common setting. Drinking my tea here. So that means that your stock tank needs to be 100 times concentrated because it's going to get diluted 100-to-1 as it goes into the water. So that's one final calculation you need to do for your fertilizer application. So going back to my previous example, if we're adding 1 gram per liter to achieve 200 ppm, the bucket should actually have 100 grams per liter as a concentration, so that what comes out gets diluted and puts back into 1 gram per liter in the water that's coming out the other side. I hope that makes sense. So here's an example. A lot of writing here, sorry, let's just work through it. The formula we're talking about would be grams per liter times the tank size times the doser setting. All right, so we've done our first calculation. We know it's 1 gram per liter. Now we know the size of the tank. Let's say it's 20 liters. So then the question here, if you want to have 200 ppm of 2820 and you have a 20 liter tank and your dosage you want to set to 1 to 150, I threw a different number in there to monkey wrench for you. So we plug the numbers in, right? 20 liter tank size, 150-to-1 dilution rate means we take 1 gram per liter times 20 times 150, which gives us 3,000 grams or 3 kilograms. in our 20-liter tank, okay? And that gives us the desired PPM coming out the other side of that fertilizer doser every time we use it. There are practical limitations I should mention, right? You can't just keep dissolving more and more salt in a certain volume of water, eventually becomes saturated. And what I would say is 3 kilograms in 20 liters is pretty darn close to the maximum you could put. So in that case, you would have to have a more dilute, concentrated stock tank and just fill it up more frequently, or get a larger stock tank. So if you are mixing it, you notice it does not completely dissolve, then you have to rethink what you're doing and work with a different PPM. So how do I know I have it right? So let's say you've done your initial calculation, you've done your injector dilution calculation. This is where we use the EC meter that we talked about last week, right? There is a known EC value for a given PPM, and that is typically on your fertilizer bag or produced as a chart, which you'll see on my next slide, that will help you get as a check. Actually, I think it's 2 slides away, but it's coming. So basically what you do is you run your water through the injector, collect the nutrient solution that comes out the other side after it's gone through the injection, and check the EC value and see if it is what you expect it to be. So for example, with 20-10-20 peat light fertilizer, we know you should have 0.33 EC for every 50 ppm of nitrogen. Okay, so that means that for every 50 ppm, we need to see 0.33 on our EC meter, assuming it's calibrated, right? And you've also subtracted the EC in the water going in. Remember that. So you would check the EC of the water going into the injector and subtract that from the EC you measure coming out of the injector, because we want to measure just the fertilizer, just what the fertilizer added. Now, typically the water we get from the city is anywhere from an EC of 0.06 to 0.1. So you'd have to subtract that from the value. So if on the other side of the injector you're getting 0.43, that means that we're getting 0.33. That's pretty good. So for 250 ppm, we would expect 5 times 0.33, which is 1.65 EC. Hopefully that makes sense. It shouldn't be too complicated. All we're doing is multiplying the known EC for the desired ppm that we're looking for. Now on this table here, you'll see on the one side, there is ppm of nitrogen, and here we have 50, 100, 150, 200, 250, 300, and over here are the different fertilizers that this company, Plant Products, happens to sell. So if we look at 14014, for a ppm of 200, we should be expecting an EC of 1.62. So these charts you can download from the fertilizer company. Often at my farm we had it posted in the fertilizer room, so you could check that to make sure the EC was correct, that you're getting the proper ppm on your crop. Hopefully that makes sense.